8th standard. First we'll check what is square of a number. Then we'll check how to find out the square root of a number. Okay. So what is a square? A square means square of a number is the product of the number by itself. If you are multiplying a number by itself, you will get the square of that number. Okay. If you are multiplying a number by itself, you will get the square of that number. Example, if you are multiplying 2 by 2, what you will get? 2 2s are 4. Then 2 square is equal to 4. Okay. First I am taking natural number 1. And what is the square of that? 1 into 1, that is equal to 1 square. Then if you are multiplying 1 by 1, what you will get? 1 you will get. So this 1 square is 1. Okay. If you are taking the next natural number 2, what you will get? 2 2s are. That's equal to 2 square. 2 2s are 4. Okay. So if you are multiplying 2 by 2, you will get the square of 2. What is the square of 2? 4. Okay, like that. If you want to find out the square of any number, if you want to find out the square of 5, you will get 5 into 5 is equal to 25. Okay. Like that, you can find out square of any numbers, whether it is an integer or natural number. Okay. If you are taking an integer minus 1, if you are taking an integer minus 1, how will you find out the square of minus 1? Minus 1 square is equal to, you should multiply minus 1 twice, isn't it? That means minus 1 into minus 1 you should do. And if you are multiplying, then what you will get? Minus of minus will become plus 1 into 1 is equal to 1. Then what you got? You got minus 1 square, that's equal to 1. Like that, if you are finding out minus 3 square, okay, minus 3 square is equal to what you should do? You should multiply minus 3 by minus 3, then minus of minus will become plus 3 3s are 9. You got the square of minus 3 as 9, isn't it? So like that, you can find out any number square, okay. If it is a larger number also, if you want to find out 25 square, what you should do? 25 into 25, then the result will be the square of 25, isn't it? Okay, then we will go to the next point. Square of a natural number is called square numbers of perfect square. If you are taking a natural number, okay, if you are taking a natural number 1 and it's square, what is 1 square? 1 square is equal to 1, isn't it? So 1 is called square number of perfect square. Okay, 1 is a square number or perfect square. If you are taking another natural number 2, what will happen? 2 square you got as 4. So what is the next perfect square? 4 is the next perfect square. Like that, if you are taking square of 3, what will you get? 9 you will get. So 9 is the next perfect square. So square of a natural number is called square number or perfect square. Okay. So you can see that 1, 4, 9, which one will be the next square number? 4 square. 4 square is equal to what? 16. So 16 will be the next perfect square. Okay. So you should remember this term perfect square. And what is the next point? All the natural numbers are not perfect squares. All the natural numbers are not perfect square. How will you check that? We can find out that in between 1 and 4, you know that 1 and 2 are consecutive numbers. So 1 square is equal to 1 and 2 square is equal to 4. And in between this 1 and 4, 2 and 3 are coming, isn't it? 2 and 3 are coming. Whether 2 is a perfect, that means whether 2 is a square number, no. If you are multiplying any natural number by itself, you will never get 2, isn't it? And if you are multiplying any natural number by itself, you will never get 3. So 2 and 3 are not perfect square. So this is not perfect, not perfect. And here in between 4 and 9, so 2 square is equal to 4, 3 square is equal to 9. In between 4 and 9, 5, 6, 7, 8, up to 8 is coming. 5, 6, 7, 8 are coming. That numbers are also not perfect, isn't it? Okay, so that is the third point. All the natural numbers are not perfect squares. Okay, we will check the next point about square. What is the next point? A perfect square can always be expressed as the product of pairs of equal primes. That means if it is a perfect square, you can be expressed that as the product of pairs of equal primes. That means what? If you are taking a perfect square, 16 is a perfect square, isn't it? So we are going to factorize that 16. What will happen? It is divisible by 2. 16 divided by 2 is 8. Again it is divisible by 2. 8 divided by 2 is 4. If you are again dividing by 2, what will happen? 2. Okay. So what is the prime factorization of 16? 16 is equal to 2 into 2 into 2 into 2. Okay, what is the fact given here? A perfect square can always be expressed as the product of pairs of equal prime. I am going to pair the prime factors what I got here. Okay, so while I am making pair, I know that 2 is existing as pair, this also existing as pairs. Okay, so 16 I can express as the product of equal primes, isn't it? 16 I can express as the product of equal primes. Okay, so every perfect number like this, every perfect square you can express as the product of equal primes. What is the use of this fact? Why we are using this? Where we are using this fact? To check whether a number is a perfect square or not. If you got a number like 32, we should check whether it is a perfect number or not. For that, what we should do? First, we should factorize this, and we want to check whether we can write as the product of pairs of equal primes. If we are not able to write it as the product of pairs of equal primes, it is not a square number. We will check that. So, we should factorize this 32. It is divisible by 2. Then 1 2s are 2. 12 by 2 is equal to 6, isn't it? Again, it is divisible by 2. 16 by 2 is equal to 8. Again, it is divisible by 2. 4 2s are 8. Again, divisible by 2. Okay. 2 divided by 2 is equal to 1. So, how can we write this 32? 32 is equal to how many 2s? 1, 2, 3, 4, 5 2s. 1, 2, 3, 4, 5. Okay, I am going to make this factors as pairs. So, what will happen? So, this 2 are become a pair, this again become a pair, and you can see from here that 1, 2 is left unpaired. So, this 2 has no pair. So, what you can see from that? What you can say from that? You can say that 32 is not a perfect square. Why? Because we couldn't write this as the product of pairs of equal primes. Okay. So, this is not a perfect square. So, you should check, you should first find out the prime factorization of the given number, and if you could not make it as pairs, if you are not able to make it as pairs of equal prime, you can say that it is not perfect. Okay, we will check one more example. Here we have taken two numbers 90 and 324. We should check whether these numbers are perfect square or not. Okay, whether these numbers are perfect square. For that, what we should do? We should do the prime factorization of these two numbers. What do we mean by prime factorization? You should divide only by prime numbers, isn't it? If you don't know about prime factorization, you don't know how to find out the prime factorization of a number, you check in my channel. Already I uploaded prime factorization of numbers. Okay. So, we will take the first question 90 and we should find out the prime factorization of 90. It is divisible by 2. So, if you are dividing by 2, what will happen? 45 you will get. Again, it is divisible by 3. If you are dividing by 3, 45 by 3, what will you get? 1, 3 are 3, 15. 5 3 are 15, isn't it? Again, you can divide this by 3. What will happen? 5 3 are 15 and 5. 5 divided by 5 is equal to 1. Okay. So, what is the prime factorization of 90? 90 is equal to 2 into 3 into 3 into 5. Okay. So, listen here. Whether this number is perfect, whether this number is a perfect square? No. Why? We can pair this prime factors, but how can we pair? We can pair like this, isn't it? But these are not equal primes. 2 and 3 are not equal. No. So how can you factorize? How can you pair like this? This is the wrong method. So what you should do? 2 into 3 into 3 into 5. Here you should make it as pairs of equal primes. Here 3 and 3 are equal prime. So you can make it as a pair. What about 2? 2 don't have other pairs. So 2 is left unpaired here. 5 is also left unpaired. So this 90 is not a perfect square. Not perfect. Okay. Like this you should do. What you should do? You should prime factorize first and you should make it as pairs of equal primes. Okay. And if the prime factors are left unpaired, you can say that that number is not a perfect square. We will check for another example 324. So it is divisible by 2. 12 divided by 2 is equal to 6. Again 2 2s are 4. It is divisible again by 2. 8 2s are 16. 2 divided by 2 is equal to 1. then divided by 3. What will happen? 81 divided by 3, 27, isn't it? 27. If you are again dividing this by 3, what will happen? 9 3s are 27, 3 3s are 9, up to 1 we should do, isn't it? So this is the prime factorization of 324. Whether this okay, you will write the prime factorization of 324 here. Whether it is a perfect square or not. 2 into 2, how many 2s? 2 into 2, 2 2s, how many 4s? Sorry, how many 3s? 4 3s. Okay, while making it as pairs, what will happen? We can see that all the prime factors are existing as pairs only, equal pairs. Okay, here 2 has one pair, 3 has one pair, again 3 has one more pair. That means this 324 is a perfect square number. Okay, I hope all of you understood this. How to find out the square of a number and how to find out how to check whether a number is perfect square or not. If you have any doubt, you can ask me through the comment box. Thank you for watching.